Welcome to this week's exam video. This is Autumn 1, Week 5 exam on the electrolysis of aqueous salts. Before we begin, it's really important that you're absolutely clear on how to work out questions about electrolysis. The best thing to do whenever you're asked a question on electrolysis is to first decide whether your electrolyte is molten or aqueous. If it's molten, it means it's a liquid form of the ionic compound, and we know that there will be two ions, one positive ion, one negative ion. The positive ion will go to the cathode and you will form a metal, because in electrolysis ions are discharged and become metals. At the anode, the negative non-metal ion will go to the anode and become a neutral element, a non-metal. However, if you have an aqueous solution instead of a molten ionic compound, there will not be two but four ions present. The extra two ions will come from water, which dissociates into H+ and OH- or hydroxide ion. And so at the negative electrode, the cathode, you will have two positive ions, H+ and the metal ion. Only one of those will form an element, and that's always the less reactive one on the reactivity series. At the anode, two ions will be attracted to the positive electrode. The two negative ions will be the hydroxide OH- ion and the non-metal ion as well. So, which one of those will be discharged? If you have a halide ion present, which means Cl-, F-, I-, then you will form the halogen gas, I2, Cl2, Br2, etc. If not, then your hydroxide ion will be discharged and form oxygen gas. This is essential knowledge for you to be able to answer these types of questions. So let's move on to question 1. This question is about electrolysis. How many different elements are in the formula AgNO3? Tick one box. Remember, every element begins with a capital letter. In this case, there are 1, 2, 3 capital letters, so there are 3 elements. How many atoms are present in the formula AgNO3? Well, if we were to rewrite that with the invisible ones, we would see there is 1 silver, 1 nitrogen, and 3 oxygen atoms, so there is a total of 5 atoms. An electric current is passed through silver nitrate solution. This tells me that we have H+ and OH-. Remember what we said about there being 4 ions in solutions. Figure 1 shows the apparatus. So we've got classic electrolysis setup with the solution in the beaker. The solution contains 4 ions, just like we said. Where do the H+ and OH- ions come from? Well, we know they come from water, because the water molecule dissociates into hydrogen ions and hydroxide ions. 1d. Ag+ and H+ ions are attracted to the negative electrode. Give a reason why. Well, the reason positive ions are attracted to the negative electrode is because opposite charges attract. Very simple answer to get your 1 mark. 1e. Silver is produced at the negative electrode and not hydrogen. So remember, at the negative electrode you get the positive ions H+ and Ag+, but only one of them becomes discharged. In other words, only one of them becomes an element. Which one is it? Well, the rule is always that at the cathode the less reactive element is formed. So out of H+ and Ag+, the only reason silver would be produced is because silver is less reactive than hydrogen. 1f. The hydroxide ion is attracted to the positive electrode. The equation shows what happens at the positive electrode, or the anode. So we've got 4 OH- produces 2 H2O plus O2 plus 4 electrons. Name the gas produced at the positive electrode. Well, we can see from the equation that the gas produced is going to be oxygen, because that is O2. Water would just be liquid. 1g. An electric current is passed through sodium chloride solution. Remember, I see the word solution and I immediately think to myself, I've got a solution, there must be 4 ions. Figure 2 shows the apparatus. Again, similar setup, this time with a solution of sodium chloride. After passing an electric current through sodium chloride solution, one product is sodium hydroxide solution. So the reason sodium hydroxide is produced is because although you get chlorine discharged and hydrogen discharged, if we think to the 4 ions that are present in our solution, sodium chloride, we have Na+, H+, Cl-, OH-. Only chlorine is produced at the positive electrode, because whenever you have a halide ion present, it is discharged, not the OH-. And whenever you have a metal and hydrogen, the less reactive element forms, so you form hydrogen. This means that you have left behind in the solution, you've got sodium ions and OH- ions. Together we call that sodium hydroxide solution, which is why it is a product, NaOH. NaOH. The presence of sodium hydroxide can be shown by adding an indicator. Name an indicator and give the color of the indicator in sodium hydroxide solution. Well, we know that the most common indicator we can use is universal indicator, but you can also use litmus paper. Hydroxide is a big clue because all metal hydroxides that are soluble are alkalis, and we know alkalis turn universal indicator blue or purple, or litmus paper just blue. Question 2. A student investigated the electrolysis of different concentrations of sodium chloride solution. Now, as I'm reading that, I'm immediately thinking there's an investigation, and the thing that's being changed is the sodium chloride solution concentration. So immediately I'm going to label that as my independent variable. Figure 1 shows the apparatus used. And remember, because it's solution, I've got 4 ions. So this looks slightly different to the usual setup, and that's because any gas that's produced is being collected in these upside down measuring cylinders. As gas bubbles are produced, the gas pushes the water out, and that allows us to measure the volume of gas produced. So the measuring cylinder records the volume of gas produced. Now if that's something we're measuring, I'm going to bet that that's the dependent variable, so I'm going to write dV there. The student recorded the volume of hydrogen gas produced in 10 minutes, and that seems to be one of the control variables. The table shows the student's results. Now remember, tables often give us clues as to what is the independent and dependent variables, because independent variables are usually recorded on the left-hand side, whilst the dependent variables are recorded on the right-hand side of the table. So this confirms my recognizing of the independent and the dependent variables here. So the question is asking us to plot the data from the table on the graph. Now there are 3 things here, and as I was answering this question, I made little check boxes for myself so that I could tick them off to make sure I get all the marks. First thing I did was label the axis X and Y. On the x-axis you should always have the independent variable, which is why I've put concentration of sodium chloride solution, and I've put the units as well. On the y-axis you should always put the dependent variable, which is why I have written the volume of hydrogen gas produced in 10 minutes. In centimeters cubed, which I should probably add in as well, so centimeters cubed. Then I need to use suitable scales. Now your scales should be evenly spaced out so that the gap between each interval is the same, and your graph should take up at least half of the page. So I go just over half here, and I go just over half the axis here. So I've gone up in 20s for every 10 boxes here, and I've made myself a little key which makes it easier for me to plot. I've said 1 little box equals 2 grams per dm cubed, and over here I've written 1 little box equals 0.2 centimeters cubed. That helps me with plotting my data. So you get a mark, 2 marks for plotting the data correctly, 1 mark for drawing a correct line of best fit, and you get 1 mark for labeling the axis using sensible scales and at least half of the graph. The question asked is describe the trend shown by a graph. Well, first of all, I can more simply say that as the concentration of sodium chloride increases, the volume of hydrogen gas collected increases, but I also know this relationship is directly proportional because it's a straight line. So you get the mark for saying either one of these, but it's best to get into the practice of saying directly proportional when you see a straight line graph. Next, this confirms what I already knew. There's a question asking about dependent and independent variables, and I was able to write those down immediately. Just to help me remind myself, I can remember that what you change is the independent variable, what you measure is the dependent variable by using the mnemonic chimed. Question 2D is about explaining how chlorine gas is produced at the positive electrode. Well, this is quite straightforward because it's the same as explaining why any product is made at any electrode. There's always 4 marks available for this type of question. Firstly, we need to think about the charge of the ions. Chloride ions are negatively charged and so attracted to the positive electrode because opposite charges attract. That gets you 2 marks. The third mark is for saying the chloride ions lose an electron each, or you can say chloride ions are oxidized, and the final mark is for saying to form chlorine molecules, because remember they are neutral. If you said atoms instead of molecules, you could also get the mark. Now, instead of saying the final 2 points, you could have just written the half equation, which is 2Cl- produces Cl2 plus 2 electrons. 2E. Sodium ions and hydrogen ions are attracted to the negative electrode. Why is hydrogen gas produced at the negative electrode? Now, because I like to imagine exactly what's going on, I often write the charges and of the ions above the words, and that helps me imagine them moving to the negative electrode. And I think to myself, the reason hydrogen is produced is because, again, I need to remember the rule. See if you can write the rule down with your blue pen. Now the answer is that hydrogen is less reactive than sodium, and we know the rule is the less reactive element forms at the negative electrode. 2F. The student made 50 centimeters cubed of sodium chloride solution of concentration 29.25 grams per dm cubed. How many moles of sodium chloride did the student use to make 50 centimeters cubed of the solution? And you're given different relative atomic masses here. Now this is a very tricky question because it involves 2 separate calculations. But if we follow the method that you have been taught, you will find this relatively straightforward. So the first thing to do is always to bug our question like I've done here. The next thing we need to do is to list the values. Now I'm going to show you and do this live so that you can see exactly how I work this one out. So the first thing is listing the values. So we know they made 50 centimeters cubed of sodium chloride solution, so I know my volume equals 50 centimeters cubed. Did you list the values? If you didn't, write them in now on a separate piece of paper. Second, we know the concentration. Concentration equals 29.25 grams per decimeter cubed. How many moles of sodium chloride? So I need to work out the number of moles, which is N. I'm going to put question mark moles. And finally, I'm given the relative atomic masses, which tells me I need to work out sodium chloride's relative formula mass. So I'm going to write down NaCl's relative formula mass, NaCl, so it's going to be 23 plus 35.5, which gives me 58.5. Okay, now my immediate thought now is which formula links all of these together? Well, I don't think there's any one formula that links these together, but I do know that in order for me to work out number of moles, I need the mass and the MR. So I'm thinking there must be a way for me to figure out the mass in grams. And that reminds me that actually volume and concentration are part of a formula. Concentration equals mass divided by volume. So maybe those are the two formula I need to use. So if we write down that formula, concentration equals mass divided by volume, immediately I'm thinking volume needs to be measured in dm cubed, so I'm going to divide 50 centimeters cubed by 1000 to get 0.05 decimeters cubed. I now substitute my values, so I have 29.25 rather equals mass divided by 0.05 dm cubed. If I multiply both sides by 0.05, I get 0.05 multiplied by 29.25 equals the mass, and when I put that into my calculator, I get mass equals, in fact I can show you here, I get mass equals 1.4625 grams. So I know my mass now, so I can substitute that into my next formula, which is number of moles equals mass divided by MR. I can substitute M mass and MR as 1.4625 and 58.5, which I worked out here. And finally, I get my final answer, which is 0.025 moles. So I'd write that in as my final answer. So this was tricky because you needed to use one formula to find out the mass and substitute that into a second formula to find out the number of moles. But if I follow my method of listing the values first, I can work it out. If you don't follow the method, you will struggle. Question 3 is another electrolysis question about magnesium chloride. There are two experiments here, one with molten and one with dissolved magnesium chloride. The first question is about why it must be molten or dissolved to be electrolyzed. Well, we know that when it's solid, the ions are not free to move, so it cannot conduct electricity, which is essential for electrolysis. But we know that when molten or dissolved, they can move. So the two marks are for saying electrolysis requires the ions to be mobile, so they can move to the electrodes. Because if they can't move to the electrodes, the ions cannot be discharged, and therefore we cannot form any elements, which is what electrolysis is all about. 3AII. In experiment 2, a gas is produced at the negative electrode. Now immediately I'm thinking, what's going on here? We've got two positive ions, and we know that if a gas is produced, it must be hydrogen. Name the gas produced. Well, there we go, it's hydrogen. So you can see I'm already starting to think what the question might be just by using the information they're giving me. Next question, suggest why magnesium is not produced at the negative electrode in experiment 2. Well, again, what's the rule at the negative electrode? Can you remember? The answer here is that magnesium is more reactive than hydrogen. Final two questions are about half equations. We need to complete and balance the half equation for the reaction at the positive electrode. Well, if I can see there are two atoms of chlorine on the product side, then I must have two ions of chloride on the left-hand side, on the reactant side. Because each chloride ion has a charge of -1, if I have two of them, there must be two electrons that are lost, and so two electrons go on the right-hand side. Final question, you need to write the balanced half equation for the reaction at the negative electrode in experiment 2. If we look at the negative electrode in the experiment 2, we know that there are hydrogen ions and there are sodium ions present, but we know that hydrogen is produced, so this is the half equation we should use. This is one you should know off by heart, two hydrogen ions, because hydrogen gas is H2, it's diatomic, and therefore we need to add two electrons to the hydrogen because it is gaining electrons. Because if you remember oil rig, oxidation is loss, reduction is gain. The hydrogen ions are being reduced to form hydrogen gas. Add up your marks out of 30 and put the total at the front. and make sure you write your marks at the front there.